Good morning, everyone. Myself Srinath. Here, I would like to discuss about the where does the far field of an antenna start. So, coming to introduction to the far field of an antenna. The far field of an antenna refers to the region in which the electromagnetic waves radiated by the antenna behave as if they were composed of parallel rays. Though that the far field is crucial for various applications, including long-range communication and radar systems, it is important to understand where the far field begins to ensure optical antenna performance. So, coming to near field versus far field, here you can also see the figure of the near field and far field. Though that the near field of an antenna is the region close to the antenna where the electromagnetic waves are not fully developed. In the near field, the energy is primarily stored in electric and magnetic fields rather than radiating as propagating waves. So, coming to the far field starts beyond a certain distance from the antenna, where the energy is predominantly in the form of a radiating waves. So coming to the distance, you can observe here how the near field and far field transition distance will occur. So the transition distance, also known as the near field far field boundary, marks the beginning of the far field. The distance depends on the physical size of the antenna and the operating frequency. You can see here where the transition distance is depend on the non-radiative, reactive, and radiative. Where coming to the near field, so it is typically determined by a rule of thumb. You can also know the rule of thumb that such as uh, lambda by 2 pi, where lambda is the wavelength of the operating frequency. So coming to the radiation pattern, you can also see here how the magnetic waves and electromagnetic waves of the radiation were occurring. So that the radiation pattern of an antenna describes how the radiated power is distributed in different directions. So that the in the far field, the radiation pattern becomes relatively constant, independent of the distance from the antenna. So that the radiation pattern in the near field is highly influenced by the antenna structure and can vary significantly. So that the where that antenna provides the near field and far field, through that we can have the calculations for far field region characteristics. So that the in the far field region, the radiated waves become more spread out and exhibits characteristics of a plane wave. The electric and magnetic fields are orthogonal to each other and to the direction of propagation. The far field region is also known as the Fraunhofer region, named after the German physicist Joseph von Fraunhofer. So that it also known as the Fraunhofer region, where that far field region is known. So coming to the antenna basis, importance of the far field is nothing but it is majorly used as the electromagnetic wave 5G lines. So that the in long range communication, the far field is where most of the signal propagation occurs. Antenna gain, directivity, and efficiency are typically specified in the far field region. So that the accurate measurements and prediction of antenna performance required considering the far field characteristics. Though that coming to the practical consideration, whether the practical consideration in the practical applications determining the far field distance can be challenged. The far field distance increases with higher frequencies and large antennas. As we know that it is so important to ensure that the antenna is placed sufficiently far away from any nearby objective or structure to avoid interference, so that we can also enhance to test that the antenna testing method, where that antenna testing facilities use chambers to simulate the far field conditions. Though that those that These chambers are designed to minimize reflections and provide an environment where the antenna's far field characteristics can be accurately measured. So, coming to the testing is the far field insurance reliable and antenna performance evaluation and compliance with regularity standards. So that you can also see how this antenna near field and far field calculations will occur. So you can see here wavelength equals to speed of light, where we can also determine by c by f. Lambda equals to c by f. So, wavelength of speed of light by frequency. Where in a near field, the antenna waves are so complexity, and it will be mixed together with that non-radiative and radiative occurs. And coming to far field, here far field is nothing but it will mainly propagates the antenna electromagnetic waves in the proper distance radiated room, where that it ends as speed of light to the frequency. So the near field of an antenna is nothing but where the region of the antenna means where the electromagnetic waves are not fully developed. So that the far field starts beyond a certain distance from the antenna, so that where we can have the energy is predominantly in the form of radiating waves, so that we can have this transition and radiation pattern and far field region characteristics. And we need to have the importance regarding the far field, so that we can also at lastly we can classify the applications of the practical consideration. So coming to, we can also test by the antennas facilities. So at last there is a conclusion that the far field of the far field of an antenna starts beyond the transition distance, where the electromagnetic waves behave as parallel rays. This is about the conclusion regarding where does the far field of antenna starts. The far field of antenna starts beyond the transition distance, where the electromagnetic waves behave as parallel rays. Let us show how the transition distance will occur. Understanding the far field characteristics is essential for optimizing antenna performances. Accurate messages, measurements, and considerations of the far field are crucial in various applications during including long range communication and radar systems. You can see transition distance of far field is occurs. See in this figure of the antenna electromagnetic waves, you can nearly observe that how that near field and far field is classified. So that the far field of an antenna will occur, and where does its exist means it will exist in the transition distance. Though that we will be classify that this transition distance also known as near field far field boundary, so that marks as the beginning of the far field. The transition distance depends on the physical size of the antenna, though that we can operate the frequencies. For further frequencies we can use as the rule of thumb rule system. By the thumb rule system, we can classify what that mainly actifies, so that where such as lambda by 2 pi, where lambda is the wavelength of the propagating frequency. Or that we can also use that classified formula that wavelength is equal to speed of the light by frequency. This is also the given specified uh, uh, given specified answer for the region. So that the our main aim is that where does the far field of an antenna starts means it is mainly fields on the transition distance, and the near field of an antenna is the region closest to the antenna, so that the where the electromagnetic waves are not fully developed. So that the far field stage starts beyond a certain distance from the antenna, where the energy is predominantly in the form of radiating waves. And here you can also, at last we will also let you know that this antenna will far field of an antenna will starts in the transition distance. Thank you for having this.